in this particular built environment space, working with a residential construction company called Idea Builder. And what we do is we use a combination of digital fabrication and CNC robotics, a lot of what is very popular in Europe and places in Asia as far as advanced manufacturing, to build essentially timber components, kits of parts, and then also houses. We focus mainly on high-end. So an example of how this process is very efficient is this was a 5,000 square foot custom home that we did up in Tahoe. From foundation to dried in, so no electrical, no plumbing or anything like that. We did this in 4.5 weeks using our process. That would have taken several months to stick frame for anyone who knows about that kind of process, right? So, so we start with very good 3D CAM data, not CAD data, and then we're able to use that all the way through fabrication. So a little example of that here, and you'll have to forgive me because I don't quite. Yeah, here we go. All right. Just a little example of the level of detail that we have here. This is our timber fabricator engineer, Stefan Schneider, who's just going through and again showing all the different elements of this house. This is also a house. I have augmented reality on the back of my business card for those that have seen it. But again, it's the timber, and then we do some steel structural elements as well. And then as you see here, he clicks on this component, and this is all the metadata about that particular beam there. So very intelligent 3D models. And this is what it gives us, right? We get super data-rich models. It's not just about vertices. This isn't dumb geometry. This is actually something that has properties and whatnot that most of us are familiar with, especially architects that use Revit and some of these other things. And then that really helps in this. I won't say this because I heard that a kitten dies or something like that every time someone uses this word. But again, my job is really looking at how do we use the data that starts with the architect and really put it not just in a way that benefits us, but also adds value all throughout this part of the building's life cycle. So I am a big standards guy. If you see what it is, a lot of what I talk about is about ISO standards and other industry standards for data exchange to help with this. The next part that we're going to go on to then is the interactive elements. And so what's happening right now is due to advancements within HTML5, we now have 3D that runs natively in the browser. Okay, beforehand you actually have to get a client or a plugin, or there were a lot of barriers to entry in order to have this experience. And most people are familiar with Web 3D and interactive 3D in these different ways, right? So it's all pretty self-explanatory there. The way that this has been kind of used in the building industry, these two specific things actually were from around right after Katrina. This was a group called Architecture for Humanity. They used a virtual world platform, and for those that know, this will date it, called Second Life, where essentially different architects from all around the world were able to come in and then collaborate on designs for these humanitarian structures that were built down there for those that lost their homes. This was an application that we built internally that helped essentially students understand different things as far as like sustainable building materials, insulation, and it was quite an interactive house. So you could go around and learn different things as far as how does home automation plug into this, and it kind of became an interactive training manual. This was for a builder that wanted to show the assembly, the modular assembly of how these units in Aspen, these were essentially, you know, this is where the help lives kind of thing, you can tell by the design. But they wanted to show how those were going to go together, and then you could see that. But then when that animation was finished, it actually unlocked the ability for you to freely navigate around the space, and then you could click on the different elements to find out what is the SIP panel, what is the thermal values of these windows, and these types of things. So these examples right here are actually 8 years old, to tell you anything about how long this technology is being used this way. Now let's move a little bit forward to where we are today. Interactive on human-computer interface. I'm sure everyone in here, I know of one person I'm a fan of that's been using virtual reality, it sounds like, and some other things, are familiar with the Google Glass. This is a company called Infinite Z. That's their Z-Space device. With particular glasses and a stylus, you can pull things out of the screen and look at this. Down here what you have is you have a depth camera that's embedded into the laptops. As I mentioned last night, a lot of these connect depth cameras and the things that you see when you see kids waving their hands around and whatnot. These are going to be in your computers, phones, and tablets probably within the next 12 to 14 months. They're already starting to make their way into some of the commercial builds now, and Intel has an initiative called RealSense, which is working with OEMs to throw this pretty much up where your webcam is. So the ability for you to be able to wave your hands around and do Minority Report anything is pretty much already here. And then of course you have the wearable technologies like Google Glass, Datarich downstairs, and others that allow for us to interact with this data in a different way. So as I mentioned, I am into web and 3D standards. These standards have been around since the late 90s for Web 3D, and this is only just a small group of people that probably no one's ever heard of that already use these standards. So definitely for those that are interested in saying, how can I ensure the longevity of my 3D data? How can I make sure that it stands the test of time? Those things are out there, and no offense, if they're good enough for these people, they're probably going to be good for your business as well. So now let's move on to this part of this. Now usually when I tell people that I'm into digital fabrication and robotic manufacturing, I know for this crowd, this doesn't really apply. But as I was sharing earlier, I was actually at a show where we had builders, the actual people swinging the hammers that came out to the job site, and no kidding, they really thought it was this, to a degree. And then I'm just a big Transformers fan. And then we do subtractive digital fabrication, so we don't 3D print houses. And so that's another thing, is when a lot of people hear of digital fabrication, they think automatically of additive and not subtractive. So that's not what I'm talking about in this particular part. The kind of manufacturing that I'm referring to, as you'll see here, is where from that same model of that home that you saw, this is in a program called Catwork. This is essentially a Swiss software that's mainly focused on timber structures and timber. And as you'll see here, this is just Stefan running essentially how this goes from the software to, this is a K2 machine, a beam processor here, and this is the kind of robotic manufacturing that it is that we're talking about. I sped this up a little bit so they don't move quite that fast, but they are pretty quick. Now, going a little bit further, this is not in our factory. This is a group up in Scandinavia that's using robotics in this way. This is for truss assembly. So as you'll see here, this speaks for itself, right? And this is probably about a year-old video that shows of how they're doing this, and if I remember correctly, it's one of the Scandinavian countries. I believe it's Finland, but I'll definitely have to find out. So again, another way that you're seeing the same efficiencies that we found in the way that the automotive industry has gone in using automation is now starting to be applied into residential construction and others. And I did not speed this one. So yeah, so just kind of some pictures here. So speed cut machines, the kind of different components that you can get out of that, which is pretty neat there for those that understand anything about carpentry and wood and whatnot. Of course, these same types of things can be used for other materials as well, steel, composites, you know, and other things with hybrid structures. These are some examples of just you know, some projects that we have done, just to kind of show you a little bit of the complexities of this and more of the residential type market. These are some examples of how this has been used in bigger projects. The Metropole Parasol in Sevilla, Spain, which was overseen by Arab, a very amazing structure, if anyone's ever seen that, out of timber. This one down here by Norman and Foster's in Switzerland. Of course, the Metz Pompidou Center here, and of course this one in Germany, all pretty much timber fabricated. Again, other ways that digital fabrication is being used. This is by Zahner and Associates, the 9/11 Museum, and some of these they did the Seattle Music Project and also the Disney Concert Hall that we heard Mortensen talk about a little bit earlier. And then also in composites, this is being done by a group called Chrysler and Associates that does everything from facades to that rabbit, if you guys have seen that in the San Diego, I believe, airport. There's also like a blue bear that's peeking in a window, if you've ever seen that one. This is the new Bing concert hall down at Stanford. If you've ever been to San Francisco, I'm sure you've seen this big bow in front of the Gap building by the Bay Bridge. And then recently, Bill and his team just finished this facade of the new wing of the SF MoMA there in San Francisco. All a very amazing building. And they also did, for those that remember the movie Minority Report, the precog chamber and some of the things in the original Star Wars movies. So just a quick little why would I use this? And how far into the future is this? You saw the date on there, right? 2007. Okay? Now, it's not that I'm using an old slide, it's just I want people to realize that these aren't new technologies, right? So just a quick show of hands. How many people in here are familiar with digital fabrication in the building industry? Rather well. Okay, there's a couple, but then a couple now. Awesome. So we'll skip Norman there. And then showing how all this comes together. So I like to refer to this as tech mixology. You take very good data, 3D building data, you mix that with the ability of runtime environments that allow for interactivity, mix that up with a variety of different interfaces for us to do that, and then you get some pretty interesting examples. So this is an application that we built where we took interactive 3D and we took digital fabrication and we had something appear down here. Yes? So what you're going to see in this application is this was a solution, our own internal hackathon, where we would have general contractors send us 2D blueprints and say, bid on this. Our guys would build that entire thing in 3D in the CAM software to give an accurate bid back. Now one can imagine the amount of wasted hours that could be on a bid if that bid does not go through. So over time, we built up a library of these different fabrication-ready components, and we said, hey, what if we gave them the opportunity to go into the environment and snap together the shell of a structure, much like you can do with Lego bricks. You get this little instruction thing, you select what bricks you want, and stick them together. And so what you're seeing here, this is where we wanted to show how fabrication data could play with geospatial data as well. This is a tool called City Engine that's now owned by Esri, a geospatial company. Beforehand it came out from a company called Procedural, that Swiss tech for essentially very quickly through parametric design building large urban environments, right? So anyone that's familiar with modeling, if you had to build out a whole city, that would take a whole lot of time. In this, another one of those that I didn't really speed up the video. It happened that quickly. So we took that data, we mixed it with the Oculus Rift, and then what you'll see here is you'll see some hands floating in space. That's these Hydra hand controllers. We know the XYZ due to this base station and the Oculus Rift. So what you're going to see is through the actual eyes of the Oculus Rift. And we decided, Batman shouldn't be the only one with a cool utility belt. So you are a builder. You have these different things here that allow you to activate different components. So what you're seeing is you select one of these pieces of geometry, it instantiates into the scene. You can turn on a feature that allows you to see the individual metadata about this piece, as well as turn on and off your panel. And then as you see when it looks up, there's a total cost calculator for the project above hand. Now I do want to say, for our fabrication guys, and since this is being recorded, that is not the cost of a wall panel. Those are values that the engineering team put in as placeholders, so you cannot get that for $40. Again, just showing how you could snap together these different things all into one scene. We took arbitrary geospatial data to generate the city in the background. There's your blueprint, and there's your individual components. But again, this is not just dumb geometry, right? This is fabrication ready. So someone snaps it together, they get their ballpark cost. We look at that, make sure it's all good, and then that goes directly to these machines for CNC fabrication, right? So now we have just demonstrated a year and a half ago how you could take immersive virtual reality and tie that directly to digital fabrication data. So, moving along, this is a group that for those that are interested into digital fabrication to definitely check out. This is called the Digital Fabrication Network. This is a group of fabricators for fabricators. Because a big issue is if you want to build a Zaha Hadid building or a Frank Gehry building, who do you go to? Who do you trust? And so this was a network of people that came together, really no small names there, that said, hey, let's form an organization where we can all work together and go ahead and move this forward. And so it has board members, everyone from, again, some of the projects that I showed earlier, to Carl Bass, who's the CEO of Autodesk, Bob McNeil, who's the CEO of a company called Rhino 3D, and then some amazing architects from around the world. Of course, a big issue we run into, though, is, even with us, is we have to import our engineers over from Europe. Where in the United States are they teaching architects, construction managers, and people in carpentry about these technologies? Exactly, I see some head nods with the no. So, believe it or not, Laney College, a community college in Oakland, started the first cross-disciplinary program where they invited people from their architecture department, their carpentry department, and their construction management department, and they have started the first digital fabrication course in the West Coast. I'd say the whole US, but that's kind of, I'm just going to say West Coast. In case someone else has done it, to teach students the whole process of from design to build, or design, manufacture to build, and they all collaborate. I actually re-enrolled back in college to actually see what this class was all about, and I'd have to say it was really interesting. It was really amazing to see the way that, one, the architecture students were amazed because it dawned on them that, hey, if we understand the constraints of these machines, that impacts our design. We know what we can and we can't design for. And then, of course, the timber people and the carpentry people saw this as a value add. Wow, now I have an additional tool to help me do what I need to, so then when that comes off, I can add the hand thing to it. And then, of course, from those that are involved with the construction management and the assembly, that's where then the computer science people and other people at Laney College that are normally making games can make applications now that show how these assemblies can go together. So, as we have buildings that are being put together better, and as we're having, the next generation of people now that are starting to do this, we're also seeing this happening. The reality of a smart, connected everything. The Internet of Things is smashing into the built environment. And whether you want to like it or not, the amount of data now that's being collected on us, either by our Fitbits, our phones, as we saw downstairs by someone here, cameras that just see you walking by and know where you are. This is going to have a huge impact on the built environment. Already you're seeing down here, this is a project that's about 5 years old, a collaboration between Fuji Xerox Palo Alto Research Laboratory and a Cho chocolate factory out in San Francisco that has moved since this. But what they did is they took the 3D model that an architect created, and then they put it into, one, a virtual world environment, so that way the executives back in Japan could come and visit and see what the factory was about. They also then added a layer where if you had, you could come and actually visit the chocolate factory as a tourist. Feel free to go see it for yourselves online. Just look up Virtual Cho, TCHO. And then also, if you had the right permissions, you could access the actual application layer that allowed you to control certain elements of that factory. So now we're talking about one model that becomes like the iPhone or the app. You can develop different apps that, depending upon your permissions, can access different data and different functionality. And so, Probably at this time I get some people that are usually saying this to the whole thing, but I see by some head nods that everyone here kind of, you guys are a pretty clever bunch, so I doubt there's too much of that. So I enjoy this because, you know, one, this I've heard my entire life, and obviously it's been around for quite some time. And so what technology is allowing for us to do now is we can work together better. We definitely can do this a lot better. It is no longer a technological issue. This is now cultural, okay? And if we're trying to embrace the next wave of people who want to do this and get into this when everybody else is going into finance and tech, we need to start speaking their language. And then also, at the end of the day, it's really about this. So with that, I always like to end on this. So again, thank you for your time, and any questions? I was either really good or really boring. All right, awesome, okay.